Venus. The planet that broke every spacecraft we sent. Every clear morning and every clear evening, there is one object in the sky that outshines everything else. Not a star, not a satellite, a planet. It hangs in the pre-dawn eastern sky like a beacon, so bright it sometimes casts a faint shadow. Ancient civilizations called it the morning star. Poets wrote about it for centuries. We call it Venus. And in 1984, the Soviet Union sent a spacecraft to the surface of that planet, and what it found there is still not fully explained today. This is the story of the most hostile world in our solar system. A world so violent, so extreme, and so relentless that it has destroyed nearly every machine humanity has ever pointed at it. A world that sits just 26 million miles from Earth, closer to us than any other planet, and yet remains, in many ways, more alien and more mysterious than the frozen moons of Jupiter or the distant surface of Mars. And the deeper you go into this story, the more you realize that Venus doesn't just challenge our engineering. It challenges our most fundamental assumptions about what a planet is supposed to be. Let's go back to where it all began. The year is 1957. The Cold War is not just a geopolitical standoff. It is a race for technological supremacy that has expanded beyond Earth's surface and into space itself. The Soviet Union launches Sputnik 1, the world's first artificial satellite, and the psychological shockwave it sends through the United States is enormous. Then, in 1961, Soviet cosmonaut Yuri Gagarin becomes the first human being to travel to space. America is behind, and American leadership knows it. Both superpowers understood that space was the ultimate arena for demonstrating national power. And after the moon, the next obvious target was the nearest planet, Venus, Earth's closest planetary neighbor, roughly 95% the size of Earth, wrapped in a thick atmosphere, orbiting just one step inward from the Sun. Early scientific consensus held that Venus might actually be hospitable, that beneath those dense clouds, conditions might support some form of life. The idea wasn't fringe science. It was taken seriously by credible researchers on both sides of the Cold War. The Soviets moved first. In 1961, they launched the Venera 1 probe, strapped to the nose of a ballistic missile aimed at Venus. The probe reached within roughly 60,000 miles of its target, and then the Sun destroyed it. The intense solar radiation at that range disabled the probe's thermal sensors, and on February 17, 1961, Venera 1 transmitted its last signal and went silent forever. It was the first of many defeats. But the Soviets were not the kind of organization that walked away from a problem. While Soviet engineers were redesigning their hardware, NASA launched its own probe, Mariner 2. In December 1962, Mariner 2 passed within 21,000 miles of Venus and spent 42 minutes scanning the planet. What it found immediately dismantled the optimistic theories about Venusian life. Astronomer Carl Sagan had published a paper in 1960 proposing that Venus was trapped in a runaway greenhouse effect, that its thick cloud layer was composed of greenhouse gases that had driven surface temperatures far beyond anything capable of supporting biology. Mariner 2 confirmed he was right. The surface temperature of Venus, Mariner 2 suggested, was somewhere around 460 degrees Fahrenheit, hot enough to melt lead. The atmospheric pressure was estimated to be crushing, and the thick cloud deck beginning roughly 50 miles above the surface was completely opaque to optical instruments, meaning Mariner 2 could not photograph the surface at all. NASA shifted focus to the Moon and Mars. The Soviets did not. In 1965, the Soviet space program launched Venera 2, a 963-pound spacecraft equipped with cosmic ray detectors, magnetometers, and Geiger counters, designed to pass within 15,000 miles of Venus and transmit detailed atmospheric data. It reached that distance, and then, just 38 minutes before its closest approach, its thermal protection failed, and the entire probe went dark. The Sun had won again. Venera 3 followed. On March 1, 1966, it became the first human-made object to enter the atmosphere of another planet. But its instruments had already failed before entry, and it crashed into the Venusian surface without transmitting a single reading. 46 years of human civilization's engineering capacity, and we had managed to throw a metal box at Venus without learning anything from the impact. The Soviets went back to the drawing board. Venera 4 was built to withstand up to 400 degrees Celsius and 25 atmospheres of pressure conditions so extreme they were difficult to even simulate on Earth. When it entered the Venusian atmosphere in October 1967, it began transmitting data. At 32 miles above the surface, the temperature was a relatively moderate 91 degrees Fahrenheit, with pressure similar to sea level on Earth. Scientists reading the telemetry back in Moscow briefly felt something that resembled hope. That hope lasted approximately 26 miles. As Venera 4 descended, the temperature didn't rise gradually. It spiked. By the time the probe had descended to 16 miles above the surface, the temperature had reached 504 degrees Fahrenheit, and the atmospheric pressure had hit 22 atmospheres. The capsule imploded, crushed inward by forces it was never designed to withstand, long before it ever reached the ground. Around the same time, NASA's Mariner 5 passed within 2,500 miles of Venus, and scientists combined data from both probes to construct the most complete picture of Venus yet assembled. What they found was a portrait of a planet gone wrong in almost every conceivable way. Surface temperature, approximately 900 degrees Fahrenheit. Atmospheric pressure at ground level, roughly 90 times the pressure at sea level on Earth, equivalent to the crushing weight of water nearly a mile beneath the ocean's surface. Atmospheric composition, 95% carbon dioxide, with thick clouds of sulfuric acid. Oxygen, less than 1%. Venus was not a potential home for life. Venus was, by every measurable standard, a furnace. But Soviet engineers now understood the enemy. If the probe had to survive 90 atmospheres of crushing pressure and 900-degree heat, they would build something that could take it. They turned to submarine technology, the same engineering principles used to build vessels that survive the extreme pressures of deep ocean environments, and applied them to spacecraft design. The result was Venera 7, a titanium-hulled egg-shaped capsule weighing 1,080 pounds, rated to withstand 180 atmospheres of pressure and temperatures up to 1,000 degrees Fahrenheit. Venera 7 launched in 1970. It entered the Venusian atmosphere. Its parachute tore apart at an altitude of 6 miles, sending the capsule into freefall at 35 miles per hour. It hit the surface hard. Most communication systems failed on impact, but one medium-gain antenna kept functioning. For 23 uninterrupted minutes, Venera 7 transmitted data from the surface of Venus, the first human-made object to successfully land on another planet and survive long enough to say something about it. The surface was solid rock, no soil, no sediment, just ancient, dense, volcanic stone. The Soviets were not finished. Venera 8 landed in 1972 and survived for 50 minutes, long enough to characterize the surface rock as basalt, the same material produced by volcanic lava flows on Earth. It also confirmed that sunlight, filtered through miles of toxic clouds, still reached the Venusian surface. The planet wasn't completely dark. It was more like a permanent overcast afternoon, dim, orange-tinted, and suffocating. Then came the images. Venera 9, launched in 1975, carried a camera. When it landed and transmitted its first photograph back to Earth, scientists stared at the image in silence for a long moment. It showed a landscape of sharp-edged rocks and boulders, clearly not eroded by wind or water the way Earth's surface features are. The rocks looked almost freshly broken. Scientists interpreted this as evidence of recent geological, or rather, volcanic activity. Venus was geologically alive in a way no one had fully anticipated. 6 days later, Venera 10 landed at a different location and transmitted a panoramic image showing flatter, older-looking terrain. 2 locations, 2 completely different geological personalities. The most technologically capable mission in the entire Venera program came in 1981. Venera 13 landed on March 1st and did something no previous spacecraft had done on the surface of another planet. It listened. The probe carried a microphone. For the first time in human history, we heard the sounds of another world. What the microphone recorded was the howl of Venusian winds, a deep, resonant roar that sounded nothing like anything in Earth's atmosphere. The winds near the surface of Venus move relatively slowly compared to the upper cloud layers, where wind speeds exceed 200 miles per hour. But the density of Venus's atmosphere is so extreme that even a slow-moving Venusian wind carries the physical force of a fast-moving current of water. A gentle Venusian breeze would knock a person off their feet. Venera 13 also carried a color camera, a drilling system for analyzing surface rock, and a seismometer. It returned 14 color photographs before the heat finally claimed it, 127 minutes after landing, more than double what anyone had reasonably expected. One of those photographs generated controversy that echoed for years. In the image, a small object near the edge of the frame appeared to have a segmented, scorpion-like shape. Soviet scientist Leonid Kazan-Fomality formally proposed, in a 2012 research paper, that the object moved between photographs and might represent biological life. The claim made international headlines. It was later determined that the object was the lens cap from one of Venera 13's own cameras, which had fallen off during landing and warped in the extreme heat into an unusual shape. But the fact that a credible scientist had looked at photographs of the Venusian surface and seen something he genuinely could not immediately explain, that says something about how little we truly understood. With Venera 14 also successfully returning data in 1982, the Soviet Venera program had achieved something remarkable. Across more than 2 decades, through mission after failed mission, they had landed working spacecraft on the surface of the most hostile planetary environment in the inner solar system. They had photographed it, measured it, drilled into it, and listened to its alien weather. And then the Soviet Union collapsed in 1991, and the Venera program ended with it. No nation has successfully landed a spacecraft on Venus since. That is not an accident. The engineering challenge of surviving on the Venusian surface for any meaningful length of time remains, by consensus of the global aerospace community, one of the hardest problems in planetary exploration. Standard electronics, the kind that run every spacecraft NASA and other agencies currently operate, begin failing at around 250 degrees Fahrenheit. Venus's surface sits at nearly 900. Standard battery chemistry stops working under extreme pressure. Standard lubricants vaporize. Standard seals fail. everything that makes a spacecraft function on Earth or Mars stops functioning on Venus within minutes. NASA has studied potential future missions to Venus under the Da Vinci and Veritas programs. The European Space Agency has the Envision mission in planning. But sending a probe that can survive long enough to conduct meaningful science on the surface of Venus, not just survive the descent, but actually work there for hours, remains an unsolved challenge. In the meantime, Venus keeps its secrets behind a wall of sulfuric acid clouds and 900-degree heat. The brightest object in our night sky. The planet most similar to Earth in size and structure. The planet that, somewhere in the distant past, may have had liquid water oceans and a temperate climate before something went catastrophically wrong, before a runaway greenhouse effect transformed it from Earth's twin into Earth's nightmare. Scientists believe studying what happened to Venus is not just an exercise in planetary science, it is a warning. A detailed, documented case study of what happens when a planet's atmosphere reaches a tipping point from which there is no return. The morning star is beautiful from 26 million miles away. Up close, it is the most complete vision of planetary destruction our solar system has to offer, and the most important one we have yet to fully read. For more amazing facts and real stories, make sure to subscribe to the channel and stay with us. Thank you for watching the video till the end.